Hey everyone, if you're just getting started with programming, you probably think the most important thing is to learn Python or Java as fast as you can. But what if I told you there's something way more important than any single programming language? Today, we're going to break down why you need to become an architect of ideas first, and only then a builder of code.
So, is programming really just about putting brackets and semicolons in the right place? I mean, it's so easy to get lost in all those tiny details. But the real creativity, the actual magic of it all, is hiding behind the syntax. And that's something a lot of beginners completely miss.
And this leads us to the biggest mistake that almost every beginner makes, falling into the code-first trap. It sounds harmless, right? But this one habit can seriously slow down your growth as a developer.
Does this path look familiar? You pick an easy language, you cram the syntax, for loops and functions, and then you immediately ask yourself, okay, how do I write this? And algorithms? That seems too complicated. We'll save that for later. And that right there is the whole problem. You're trying to figure out how to write the solution before you even understand what the solution is supposed to be. You're starting at the finish line.
So how do you get out of this trap? Well, it all starts with understanding the difference between two fundamental concepts, the idea and the instruction. In our world, that means algorithm versus code. And trust me, getting this distinction is the key to everything. This chart really lays it all out. On the left, you have the algorithm. That's the pure idea, the universal plan. On the right, you have the code, which is just a specific instruction for a specific executor. Languages and technologies are constantly changing, but a good algorithm can last for decades. Think of it this way. An algorithm is the recipe. The code is just translating that recipe into a language that a specific cook can understand.
Okay, enough with the theory, let's get practical. To make this crystal clear, we're going to use a simple, real-world example that everyone can understand: organizing books on a shelf. Imagine a messy bookshelf. Our goal is to arrange the books in alphabetical order. We're going to use a well-known method called bubble sort. Here's how it works. You take the first two books and compare their titles. If they're in the wrong order, you swap them. Simple. Then you slide over one spot and compare the second and third book, and you keep doing this all the way to the end of the shelf. That's one pass. Then you start all over, making pass after pass until you can go through the entire shelf without making a single swap. The moment that happens, you're done. This is a brilliant illustration of our point. We've just described a complete algorithm without writing a single line of code.
And now, let's see how this one single idea, our bubble sort algorithm, can be translated into completely different forms of code. This is where things get really interesting. You can express the same algorithm in countless ways. It all depends on who you're writing the instructions for.
Okay, so our first executor is a human, let's say a housekeeper. How would we give them our sorting algorithm? We just write a step-by-step checklist in plain English. That to-do list, for all intents and purposes, is their code. Now imagine a robot is sorting the books. It obviously doesn't understand English. For the robot, the code would be something different. Maybe a flowchart with pictures, or a set of commands in its own unique language. The algorithm is the same, but the way it's written down is completely different.
And finally, our main character, the computer. For the computer, the code is a program written in a language like Python, but the core logic is exactly the same. The Python script is just one more way to translate our bubble sort idea into a language that this particular executor understands. All right, but what happens when the problem gets more complex? Real-world problems are full of special cases, so let's add another layer to our problem and see how we have to adapt our algorithm.
So imagine most of our books are in English, but suddenly we find one written in Russian. What do? Do we skip it? Move it to the end? Our basic algorithm doesn't have an answer for this yet. And this is where so-called business logic comes into play. It's just a set of extra rules that tells our main algorithm what to do in special cases. For example, a rule might be, all Russian language books go to the very end of the shelf. And here's the most important part. The order of operations is always the same. First, you change the idea, the algorithm, in your head. And only after the plan is ready do you sit down and update the code. Thought first, then action. The idea always comes first. So what's the big takeaway from all of this, especially for those of you just starting your journey? Let's sum it all up.
This is a phrase worth remembering. When you solve a problem, you are an architect designing a solution, not just a bricklayer following instructions. Languages and frameworks are just tools, and they're constantly changing. But the ability to think algorithmically, to break a complex problem down into simple, elegant steps, that is a skill that will stay with you for your entire life. And to finish, a little challenge for you. The next time you have a new task in front of you, just stop. Before you write that first line of code, grab a piece of paper and sketch out the algorithm. You will be amazed at how much clearer and more effective your final solution will be.